We've been looking at the relationship between GNP per capita and under 5 mortality. GNP per capita is the independent variable and under 5 mortality is the dependent variable. And we have commented on the fact that these two variables are curvilinearly related. That is, they are not related in a straight line fashion. To recall that, let's look at the scatter chart for these two variables, and it looks like this. As GNP per capita, which is on the horizontal axis, increases, under 5 mortality decreases, but the relationship is a curved relationship, as we can see. We can use a linear relationship to account for the variance in under 5 mortality, as we have already seen, but the result is not very good. Just to recall what the proportion of the variance accounted for by a straight line would be, let's move this out of the way for the moment, and we're going to go to Tools, Data Analysis. We're going to choose Regression. OK. The Y input range will be under 5 mortality, and the X input range will be GNP per capita, and there are labels in the first row, and the output range will be in E1. Now, as this indicates, we can account for about 17% of the variance in under 5 mortality using GNP. The relationship we're accounting for is a straight line relationship. If we were to calculate the under 5 mortality predicted, it would be like this. For the first observation, GNP times the coefficient for GNP, F4 for that, plus the intercept, again F4, enter, and now I can copy these all the way down, and just to have the correct formatting, I will go to number and no decimal places. So these are the predicted values of under 5 mortality. If I go back to the graph and I add the predicted values, they now show up in pink as this straight line, and you can see that we're predicting negative values for under 5 mortality for these two countries. Obviously, this makes no sense. We've looked at a second degree curve to account for the relationship between GNP and under 5 mortality, and that was not particularly successful. Let's take a different tack now. Let's look at log values of the predictor GNP as a way of accounting for under 5 mortality, and see if using the log produces a better result. I'm going to clear this out. I'm going to clear this predicted value, and now I'm going to put a column here and GNP log. Excel will generate logs to almost any base, but if I use the function equal log and simply select the number, it will assume base 10, which is what I want it to do. And I'm going to change the formatting because the log shouldn't have a dollar value. And now I have the log value for GNP per capita. if I copy this all the way down, I can now create another chart using the log of GNP and under 5 mortality, and that chart will look like this. Now you can see that this line is much less curved than the actual value of GNP and under 5 mortality, but it's still a curvilinear relationship. Just to see how much we have improved, however, let's look at the result of regression using GNP logged and under 5 mortality. Again, I'll move the chart out of the way, and I'm going to go to Tools, Data Analysis, Regression. The Y range is now D1. The X range is C1. We still have labels in the first row, and the output will go so that we can compare the result to the simple linear regression. We'll put the output in F20, right below the original. When I say OK, we now get 53% of the variance accounted for using the log of GNP as compared to 17% using the actual value of GNP. Now again, let's put the predicted value based on the log of GNP here. This will be U5 mort predicted, and it will be equal to the log of GNP times the coefficient for the log, and that will be fixed with an F4, plus the intercept coefficient, which is again fixed with an F4. And when I hit enter, I get this predicted value for under 5 mortality. And if I click it all the way down, I can now come back with our graph and add the predicted value based on the log of GNP. And as you can see, this appears to be a better fit than the original, although again we still have negative values predicted for these countries. The last way we will incorporate the notion of logs is to take the log of both GNP and under 5 mortality and see what results derive there. I'm going to clear this, clear the contents of this column, and add a column where I will put U5 mort log. So this value will be equal to the log of under 5 mortality. And when I click this all the way down, I now have both the log of GNP and the log of under 5 mortality. And I will format this with only 2 decimal places. Now, let's look at the result of a graph. We'll take the log of GNP, and this is control. Click on the first value of under 5 mortality logged, and then control shift down arrow. Now if I create a graph, again the scatter chart, finish that. I get this result here. Now it looks as if under 5 mortality, which is measured on the vertical axis, or rather the log of under 5 mortality, is related in a straight line fashion to the log of GNP per capita. Okay, let's see how much of the variance in the log of under 5 mortality we can account for with the log of GNP. We'll move the graph out of the way again, and I will go to Tools, Data Analysis, again Regression. The dependent variable will now be the log of under 5 mortality. That's Control-Shift down arrow. And the independent variable is still the log of GNP, so it's okay. There are labels. I'll put the output this time in G, and I'll move it into G39. And when I say OK, I get these results. I've accounted for 68% of the variance in the log of under 5 mortality using the log of GNP per capita. Let's again see what this looks like on our graph. I'm going to put U5 mort log P here, and this will be equal to the log of GNP per capita times the regression coefficient for the log of GNP with an F4 plus the regression coefficient for the intercept, again with an F4. And when I hit enter, I get the first predicted value for the log of under 5 mortality. And I'll click this all the way down. And now we'll bring the graph back. And I'll drag the blue box to the right to include under the predicted value of under 5 mortality, or the predicted value of the log of under 5 mortality in the graph. And there is the straight line through the graph. So what we have discovered is that using both the log of GNP and the log of under 5 mortality gives a very good straight line fit for the data, and we have accounted for 68% of the variance in the log of under 5 mortality.